Hello, dear student. We are studying chapter number 3 of chemistry, metals and non-metals. In this chapter, we had finished with physical properties of metals and non-metals. We had started with chemical properties of metals. In the last video, we had discussed the chemical properties of metal. What happens when metal react with oxygen in air? In this part, we had discussed that metals react with oxygen in air to form metal oxide. These metal oxides are basic in nature. There are some metals which are highly reactive while others react at moderate rate and some are least or non-reactive. Look at this reactivity series. Here the metals are arranged in the order of their decreasing reactivity. Metals such as potassium and sodium react so vigorously that they catches fires. Metals such as aluminium, zinc, lead react with the oxygen and form a thin layer of oxide on their surface. This protective oxide layer prevents the metal from undergoing further oxidation. If we will see the next metal, iron, it does not burn on heating, but iron fillings, that is, pieces of iron, burns vigorously when sprinkled in the flame of the burner. Copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Silver and gold do not react with oxygen even at high temperature. Let us now study the second chemical properties of metals. What happens when metals react with water? Metals form respective metal hydroxide and hydrogen gas when they react with water. Most of the metals do not react with water. However, alkali metals like sodium and potassium react vigorously with water. To understand how metal react with water, let us now study activity 3.10 of your textbook. Again, we can collect the samples of some metals. Let us take sodium, potassium, calcium, aluminium, and iron for the experiment. You can also take silver and gold to know whether they are reactive towards water or not. Put some pieces of these samples separately in beakers half filled with cold water. We will observe which metals react with cold water. We can maintain a record of these metals reacting with the cold water. We will also notice, is there any metal which produce fire on water? Does any metal start floating after some time? Put the metals that did not react with cold water in the beakers half filled with hot water. For the metals that did not react with the hot water, we will make them react with the steam and will observe the reaction with it. Which metal does not react even with the steam? Now, on this basis of experiment, we can arrange these samples of metal in the decreasing order of reactivity with water. Let us now discuss these metals samples separately, let us now see some metals how they are reacting with water. Let us take few metal sample example and see whether they are reacting with cold water or hot water or with the steam. We will notice that some metals are highly reactive. They react with the cold water. Some metals will have moderate rate of reaction. They will react but with the hot water. Means some energy in the form of heat of hot water is provided for the reaction. We will also notice some other metals which are least reactive. They do not react with the cold and hot water. More temperature is required for their reaction. As a result, they will react with the steam. Still, there will be some metals which will not react at all with either cold water, hot water, or with the steam. Let us discuss this. Let us first see how sodium react with water. As we have already discussed one chemical property and we have seen the reactivity series in decreasing order, we know that sodium is a reactive metal. So it will react with the water and form the sodium hydroxide, and during that process hydrogen gas is evolved. You can see here in this figure how sodium is reacting. When sodium is added to the water, it starts moving quickly across the surface of the water. The sodium melt as it reacts and it becomes spherical and shining like a ball bearing. You can see here in this picture. As a result of reaction between sodium and water, hydrogen gas is produced. This hydrogen gas sometimes catches fire because of the heat from the reaction. You can see the equation of this reaction given below. Na plus H2O forms NaOH plus H2. Now let us see how potassium react with water. Potassium is also highly reactive metal. When it is added to water, it starts moving across the surface of the water very quickly. The reaction is so violent and exothermic. You know, children, what is exothermic? Exothermic means the reaction which involves the release of energy. So here, this reaction between potassium and water is exothermic. As a result, the evolved hydrogen catches fire. So we can conclude that sodium and potassium metal samples are reactive with water. They react to form the corresponding hydroxide and hydrogen gas. They react with the cold water and the reaction is exothermic. That is why the hydrogen gas release catches fire. Now let us discuss by taking the another metal, calcium. Solid calcium react with the water to produce aqueous calcium hydroxide and hydrogen gas. You can see here the equation written for the reaction. Ca plus H2O giving CaOH whole twice aqueous and hydrogen gas. Calcium react with the water, but the reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. As you can see in this figure, calcium start floating. because the bubbles of hydrogen gas formed stick to the surface of the metal. Now let us see another metal, magnesium, how it reacts with the water. Magnesium is a metal which does not react with cold water. It needs certain energy to react and to form the compound. So it will react with the hot water and will form magnesium hydroxide and hydrogen. You can see here the equation Mg plus H2O giving magnesium hydroxide MgOH whole twice plus hydrogen gas. It also starts floating as calcium due to the bubbles of hydrogen gas sticking to its surface. There are certain metals like aluminium, iron, and zinc, etc., which do not react either with the cold water or with the hot water, but they react with the steam to form the metal oxide and hydrogen. Let us see the equation given here. You can see here aluminium reacting with the steam Al plus H2O giving aluminium oxide Al2O3 plus hydrogen gas. Similarly, you will see iron reacting with water Fe plus H2O giving iron oxide Fe3O4 and hydrogen gas. There are certain metals such as lead, copper, silver, and gold which do not react with cold water, nor with the hot water, nor with the steam. They are termed as non reactive metals. So now we can conclude this chemical reaction of metal with water. You can see this table of reactivity series where the most reactive metals are placed at the top, and here the metals are arranged in the order of their decreasing reactivity. So we can conclude that the metals like potassium, sodium, calcium are highly reactive metals. They react vigorously with the cold water to form the corresponding compounds with the release of hydrogen gas. They form the metal hydroxide, and these metal hydroxide are called as alkalis. The next metal, magnesium, is less reactive. It will react to form metal hydroxide and hydrogen with the hot water. While metals you can see down, aluminium, iron, zinc, do not react with cold or hot water, but they will react with the steam and they will form the compound metal oxide and hydrogen gas. There are certain metals you can see here at the bottom: copper, mercury, silver, gold. These are least reactive or non reactive metals. They do not react with the water when they are placed into it. So, with this, we have finished with two chemical properties of metal. First one was metal reacting with oxygen in air, and the second one, metal reacting with water. Go through the book and try to understand these two chemical properties of metals. In the next video, we will be discussing the next chemical properties of metals. Students, you are aware of the PT1 examination which is going to be conducted in the next month. You are also being given the syllabus for Science PT1 examination. You can check the campus care and see the syllabus of Science PT1 examination. Go through the chapters of chemistry, biology, and physics. Read the book very carefully for the indirect questions. Also, solve your book question answer. Go through the videos of chapters of chemistry, biology, and physics again to understand the topic of the chapters which will be asked in the PT1. There will be a revision video also so that you can understand some important topics better, and we will also discuss what type of descriptive questions can be asked and how you have to answer the questions. In case you are having any doubt in the chapters of science of PT1 exam, you can message in the campus care. Through the revision videos, we are going to solve these doubts. Thank you and take care of yourself. Prepare your chapters for the PT1 examination. All the best.